Okay, we're going to be doing a somewhat brief video on exponents here. Now, exponents are used to basically write very large numbers, in a short way. For example, we'll start with a not so large number, but for example, if you ever saw this before, 3, this would be called 3 to the third power, is actually equal to 27. Let's see how that's possible. Let's break down what 3 to the third power means. Now, in 3, the large or normally written number there at the bottom, that is called your base number. And then the number at the top, which is written nice and small in the upper right-hand corner, is called the exponent. And what that means is that you're going to multiply 3 times itself 3 times. So that means 3 times 3 times 3. And I use an example like this because this is one that's commonly confused by kids, where kids often will just look at that and they think they're taking a shortcut and they just assume that it's 9. It does not mean 3 times 3. It means 3 times itself 3 times. So it's the base times the base times the base 3 times. Okay, let's follow. I like to teach kids to do this just like they're solving order of operations. If they're working out an exponent, this would be the expanded form, and if they want to put it into standard form. So 3 to the third power is 3 times 3 times 3. Use a different color. Since it's all multiplication, we can work from left to right. 3 times 3 is 9, and we bring down what we didn't use. And now 9 times 3 is 27. So we see that 3 to the third power is 27. Okay. We'll put a line down the middle and try another example. Say our base is 4, and we want to do 4 to the fourth power. A little harder one. 4 is the base. This 4 is the exponent. So 4 to the fourth means 4 times 4 times 4 times 4. 4 times 4 is 16. We're going to bring down the rest that we didn't use. We didn't use this multiplication sign, this 4, this multiplication sign, or this 4. When you're doing order of operations, you should always do one step at a time and bring down everything that you hadn't already used. So once again, since it's all multiplication, we can move from left to right. 16 times 4 is 64. Crossed it out, bring down what we didn't use, and 64 times 4 is 256. So 4 to the fourth power is 256. And when you're done with your order of operations, you'll see this in my order of operations video. It always looks like a pizza slice when you're done. Okay, I'm starting a new slide here that we can do some more examples, and then I'm going to show you some of the most common and easy exponents that you'll come across. Let's try one where we don't have the exact same base and exponent. So say we are doing, say, 5 to the third power. Once again, 5 is the base, and 3 is the exponent. Okay, 5 to the third power, that is the exponential form. Okay, 5 to the third power, we'll first write it in expanded form. 5 to the third power means 5 times 5 times 5. Then we'll do order of operations to solve it. 5 times 5 is 25. Bring down what you didn't use, and 25 times 5 is 125. So 125 is the same as the exponential form 5 to the third power. This is the standard and longer way to write it form. Now, if you are giving expanded form and you want to write something into exponential form, that's also very easy. So say you see 7, and you can also use a raised dot to represent multiplication. Say you see 7 written 5 times. That means 7 times 7 times 7 times 7 times 7. That means 7 is multiplied times itself 5 times. That would be the same as 7 to the 5th power. Or if you had a 9 multiplied times itself 6 times, that would be 9 to the 1, 2, 3, 4, 5, 6. 9 to the 6th power. Now here are those easy ones I was talking about. Tens are extra nice if you're doing 10 exponents, because tens follow a simple pattern that's easy to remember. For example, 10 to the first power is just 110. Okay, if your exponent is a 1, that means you only have that number shown one time. So 10 to the first power is 10. Now 10 to the second power means 10 times 10, which is 100. Okay, 10 to the second power, 10 times 10 is 100. Here's where you can start realizing the pattern. Now 10 to the first power, when you have a 1 exponent with tens, notice that in your 10 you only have 1 0. When your exponent is 2 with 10, notice the standard form 100 as 2 zeros, and you could probably see what's coming next. 10 to the third power, which is 10 times 10 times 10. Before I write out what it is, let's work it out. 10 times 10 is 100. Bring down what you didn't use. 100 times 10 is 1,000. Look at this. 1,000 has 3 zeros. 10 to the third power has a 3 exponent. So no matter what you do, the standard form will have the same number of zeros as the exponent. And that's the key, the same number of zeros. If you had 10 to the 7th without us working that out, that will just be a 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. We can put in our commas, and that is 10 million. So very, very easy to remember. Now I want to talk about one more. Okay, something that was not talked about earlier was squares and cubes. And the word squares and cubes are often used with exponents, and it's kind of difficult for kids to remember which is which. So I'm going to try to give you a way to remember that. Now, if the exponent is 2, say you have 4 to the second power, another way to say 4 to the second power is 4 squared. Why do we say squared? Well, here's how I try to give, here's the way I try to get kids to remember it. 4 squared is, think if we have a square. Okay? 4 squared means 4 times 4. Now 4 squared, if we were to find the area of a square, say this was 4 meters by 4 meters, what would the area of that square be? Okay, the area of that square would be 4, 8, 12, 16. So the area of that square would be 16 meters squared. Now the reason we say squared is that think of what a square is. A square is a two-dimensional figure. If you're finding the area of an object, an area of a rectangle, an area of a triangle, anything, it is a two-dimensional or flat figure. Likewise, if you are finding the volume of a cube, say we're finding the volume of a large cube which has 4-meter dimensions, we would say that this way. We can call a 3 exponent, short way to say 4 to the third power is 4 cubed. Cubed means an exponent of 3. So I'm going to draw a crude cube here. Say I have a cube with dimensions of 4. That means the length is 4 meters, the width is 4 meters, and the height is 4 meters. Cubes are three-dimensional figures, so that's why we use a 3 exponent. And to find the volume of a cube means that it is 4 units wide by 4 units long by 4 units wide by 4 units high. So that will be 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the volume of that cube is 64 cubic meters, or 64 meters cubed. So those are exponents, 10 exponents, which are very easy to remember, and why we say squared and why we say cubed.